Music is a lot like a sound. However, music is the one exception where you don't use a buffer and a sound at the same time. So music is actually a kind of a combination of a sound buffer and a sound together, because music will load pieces of that file as it's playing it. So we're going to create overtime music, a variable called overtime music. It's a type of music. And we're going to open from file. Now there's a difference between opening a file and loading from a file. Opening it means, hey, it's almost like I just want to grab this file and I want to keep my hand on it. I don't technically want to do anything with it yet. I'm just going to basically grab, put my marker on it and say, hey, I need this file. This is actually saying, get me all the contents of the file and load it into memory. This is not technically loading anything into memory just yet. It's the same thing though. We're going to load an OGG. It's a Orbis. Oh, not Orbis, Vorbis. I believe that's the name of my testsong.ogg I put. And this is actually very easy. You're just going to load it and then you're going to call play on it after you open it from file. All right. This will cause it to play right on start. But because it's also a music file, you have control over how it plays. For instance, if I wanted it so that I pressed like P to pause it, I could do that. So I could press P to pause it. So it plays on start. Or I can press P to stop it, right? Or I could press R to play it. Pause it. Notice it resumes. You can also ask whether a music file is currently playing or not. So maybe I just want P to toggle it or not, right? If overtime music is playing, there's a function called getStatus. Where you can ask to say, hey, music, are you currently playing? If you are, then pause it. Otherwise, resume. Because music is something that's constantly running, sometimes you might want to start and stop music based on what's going on in the game. So I'm hitting one key now. You can ask all these things about the music to see if it's currently doing something. So if you want to play music in your game, because maybe in your menus for your game you don't want to play music, and maybe while your game is actually in the game you actually want to play a different song. All right. So let's go over the homework. So this homework has two parts to it. The first part is I want you to add sound effects and music to Pong. Okay, so it's basically using the Pong game that you had. Use BFXR to generate some. Play a sound when the ball hits a wall. And play a sound effect whenever a point is scored.
Got him.
And add music to your game.
So how can we add more than one song, like as a playlist?
If you want to have more than one song, you have to keep track of when the first song is done. Basically, as soon as it's done playing, you have to write the code to trigger the next song.
Okay.
There's no like There's no like Windows Play. So basically say that function that I asked, that I wrote up here, to tell you whether it's playing or not. This thing will return false if the song is done. So when it's done, you need to say, okay, grab the next song and call play on that.
Okay.
And
So
when that's done, you gotta grab the next song and call play on that.
okay.
Or you can, I think you can also set this thing to loop, I believe.
Yeah, because it'd be cool if you could just get it to loop.
Yeah, you can also do this. You can set it to loop. Okay, so the homework is add sound effects and music. Then I want you to keep track of score for player 1 and player 2. I want you to give 1 point each time the ball goes out of bounds. Draw the score at the top of the screen like this. Whenever you reach 5 points scored, print out either player 1 wins or player 2 wins, based on which side had 5. Okay? Questions? Does it make sense? We're basically adding score to Pong, or adding sound effects to Pong. If anyone did not have a version of Pong running,
I have it almost done. Just need the music.
okay. I will put a version of it that's not really working. That is basically a version that looks like this, with a ball that's bouncing. So this is only for people that don't have Pong. You guys should have a version of Pong that's already mostly working from homework.
I definitely do not.
Okay, if you don't have this, Dom, you're going to need this. Because I want you to take this and make it into, one, you have to do the homework that has the ball reset to the middle, right? Because it needs to reset to the middle. And then I want you to play sounds when it hits the wall. And play sounds when you score. All right?
All right. Probably gonna put for my music something like NWA.
NWA, that's fine. I'm fine. I'm fine with that.
Maybe some.
You take the time to build the
Is this set loop wrong? Did I do that wrong? I did the thing.
Set loop is a function that takes an argument whether it's true or false.
I'm gonna do something like Sesame Street.
All right, so we're not done yet. So I'll put a CPP. I put the CPP file for Pong, a version of it that basically is somewhat working. The paddles don't move, and the ball doesn't really bounce off the right paddle. But it's close enough where you should be able to get it running with some effort. And then you get the, you're going to be able to do the homework off of that. So if you need to catch up, then this is the file that you're going to need.
I need to know my homework from the last.
Okay. So I want to go over and spend some time talking about debugging, because even though you may be doing it in Ian's class, I think that there's a lot of it that is like tricky for you guys to get. A lot of you guys are not like able to debug stuff effectively because not any fault of your own. It's just that's just how programming is a lot of times. So what I want to go over is a crash course in debugging in the last like 15 minutes that we have. And I kind of want to talk about the two different ways you can debug things. I'm going to talk about the simple way that you can always use and fall back on if you're always in trouble. And then there's the more kind of involved way, which uses Visual Studio to figure out what's going on. So what I want to do is I want to talk a little bit about those two methods, and I'm going to explain why you would use one versus the other. And this is, if you guys run into trouble from now on, even after summer break, if you guys run into trouble with your projects and you just can't figure it out, I may just tell you, I need you to debug this by yourself, which means I need you to go in there and start figuring out how it works. Because up to this point, I've been happy to help you kind of understand like where your problem is, like what line it is. For those of you guys that have been emailing me or asking questions in class about why is this thing not working? But that's not sustainable. Like, you guys have to become independent in learning how to do this stuff on your own. You can't rely on me. In fact, it's actually really bad if you have to rely on me to solve all these issues. So for instance here, we have a bouncing ball, right? And I want to solve it so that I press spacebar, and why is the ball always going up, right? Like why does the ball go up when I hit spacebar? I mean, this is a very simple kind of, this is just how this program was written. But I want to use this as an example to talk about the two different ways to debug. So the first simple way we're going to use is called, we usually call it Printf Debugging, or cout debugging, or print debugging. And it's a very simple way to work. And I want to talk about it because you can always use this. Even if you're not using Visual Studio, even if you're completely lost, you can always fall back to this. And this is kind of the first thing that I would recommend for you guys to learn, is how to use this effectively. So for instance, I just want to figure out what's happening to the ball. It looks like the velocity is changing every time I hit spacebar, and I don't really know why. And I want to know why that is. And I know why that is, but I'm just making a convoluted example here. So Printf debugging is nothing more than sprinkling cout statements throughout your code and spitting out the state of variables in your game. In this case here, I just want to print out the velocity of the ball wherever it is. Okay? So there's no real science to this other than you kind of have a general idea of where you think you might be putting this this debugging statements. And even if you don't, even if you just want to stick it somewhere, like I'm just going to stick it like right here. I don't know. I'm going to shove it right here in the beginning because I'm not sure. You're going to print out just the various pieces of what you think you are interested in. So I'm interested in the velocity because I think that's where the problem is. You always need to make sure that you include IO stream so you can do this. And I like to put a little context here, like velocity is, and I'm just going to do that. I'm just going to sprinkle that here. So I can see here the velocity is changing. Okay, every time it bounces off a wall, it looks like it's changing. It's going negative 200, negative 73. That's cool. I want to format this a little bit better so I can see the two X and Y. The goal here is that you want to start sprinkling this in to basically divide and conquer kind of where you think the problem is. So I'm hitting spacebar, and I can see the velocities in Y is changing, right? Right? So if I instead here, I'm going to add some more. You can add this to wherever you want to. I'm going to add another cout statement here. I'm going to do this after events velocity is this. And I'm just put another one that says before events velocity is this. These two cout statements seem simple enough, but it's actually very powerful where you put them. Because by looking at the logs here, I see a lot of statements that says, oh, before it was 200 and 105, and after it's 200 and 105. So before and after are remaining the same, right here. Right? They're all remaining the same. As soon as I hit spacebar, though, what I'm going to do is I'm going to hold spacebar down for a little bit. I'm going to go up and I'm going to try to find here. Can you guys see where it changed velocity? Can you guys start seeing the numbers and see how they're starting to change? Like right about in the middle, where it went from 410 to like negative 589, or like 589 to 412. So you can tell that something has changed in these numbers. Like something before and after has changed those values. Like here, before started at 410 and went to negative 589. What this means is that something in between these two has caused my velocity to change. And I know that it's between these two statements. I know it's nowhere down here. I know it's nowhere above these. It's actually exactly between these two statements. Which means when I start looking at this code, I can start identifying what actually happens here. In fact, this cout debugging is very useful because now I know I can just put one inside here. I can delete those two, and if I just move this to happen afterwards, it seems simple, but adding these sprinkled around can help you find out what the problem is. Every time I'm hitting spacebar, the velocity is changing, which helped me narrow down that, okay, that's this is why every time I hit spacebar, the velocity is bouncing, right? Here's another case. If I wasn't sure, I'll just delete these right here. If, for instance, I want to know why, let's just say here, I'm going to get rid of, a very common problem is, hey, something isn't drawing on screen, right? Like, I don't know why something isn't drawing on screen. I have this thing here. I'm going to run the game. Can anyone tell me why that happened here? In fact, I'm just going to do this. It's kind of a common problem to have. Is it like appeared and then disappeared? If you didn't see me making those code changes, how would you even start to figure out like what's happening here? Well, again, you can use the cout debugging. It appears for a second. I'm curious. I don't know where the ball is, right? So if I print out where the ball is every frame, I can get a better idea. So if I do standard cout, and this time what I'm going to do is I'm going to print out the position, and the position is the shape get position. I'm going to print out the x, and I do this all the time. This is like very similar to kind of stuff that you do at work. Is sometimes you just have no other recourse but to just you have no idea what's going on. Like you're completely just lost, and you have to solve a problem because that's your job. Is you have to fix these bugs, and you're like you might not be in an area of code where you're like you have zero idea what's happening. One of the first things you can do is just you need to put your foot down. You need to get your foot in the door to figure out, get some familiarity with it. So start sprinkling these print statements all around to get an idea. So all I'm doing is I'm going to print out the position here. I'm going to grab this. And I'm looking at the position here, and it looks really high, right? And in fact, it's high and it's moving. So I can tell that it's moving because the ball is moving to the right. And that position here tells me that the ball is off the right edge of the screen. And actually, to solve this, I'm just going to slow down the ball here because I know it's moving really fast. It goes off screen. And I know that the size of my window is 1024, so if I print out the position, I can tell, oh, well, the ball is clearly, it's there and it's moving, but it's off the edge of the screen. So I can move this here. So now I can see, okay, I move the ball, and it's correctly within the bounds, and as soon as it goes off the right side, it's gone again. All right? There is another way to do this, too. Once you've gotten familiar with cout debugging and sprinkling, like, hey, I just want to know what the state of variables are. This is really important to just basically get used to doing, is sprinkling these things around. Let's say you're at a position now where you want to know why something is off the edge of the screen, but you don't want to rebuild the entire project, right? Like, oh, well, the game is running right now. Like, it's literally running right now, and I want to know why the ball is off the screen. With cout debugging, the problem is you have to stop it. Then you have to put the code here, and then you have to rebuild it, and then rerun it again. Visual Studio has a way that lets you just stop it right wherever you want to. Like, I just want to know where it is right now. If I just put a breakpoint while the code is running, it stops it right there. Like, it stops the program from running. And then at the bottom now, there are several windows here. There's a window called Autos, a window called Locals, and a window called Watch. Autos are kind of variables that have changed recently. This is going to get you variables that are probably the ones you're interested in. Local variables are all the variables that this function or the scope of this function, this while loop can see. These are all the variables it can see. And watch window is anything you want to care about yourself. So this is where you can add in your own. We're going to start with just watch windows here. You can just take a variable and you can click and drag it. Or you can right click on a variable name, you can click add watch. Or you can type in the variable name here. Those are 3 different ways you can do it. All 3 of them are the same. What's nice about this is that you can now see what's inside those variables. So I can expand shape. I can click these little arrows. I can see the current color. I can see that the color is currently green because it has 255 for green. I can tell that it has an outline color of white but no outline thickness here. In fact, if I drill down even further, there's a transformable, which is really what I care about. And now I can see the position of it too. If you guys actually can see, this position here says that x is at 2,910, which without putting any cout statements, I can tell that this is actually off the right edge of the screen completely. Watch windows also let you do some funky stuff. Like you can actually change the value of this whenever you want to. I can actually, you can tell when I double click on it, I can edit this. I can set this back to 0. If I remove this breakpoint and then hit F5 to continue or click this button up here, looks like it moved too fast again. Some things don't really work well. Let's try this. Let's try outline thickness here. So although you could change the variables, notice here it went right back to 3000. Like I set it to 0.1, and see how it went back up to 1800. This is because sometimes, even though you can change variables here, see how it moved right off the edge of the screen? It doesn't always get you the behavior that you want, because you know what's happening actually in the background right now? This clock is actually still running. So keep in mind that even though you can change variables, like I can change the size of this. If I do this fast enough, if I break it and then set it back to 0, you have to kind of be quick. This is not a great way to debug this, but I just want to show you guys that you can do this. You can set up the watch window. You can sometimes get the ball to still show up, which just proves to me that that ball is going off the edge of the screen. I can look at all kinds of other variables too. Like I can look at delta time. You guys ever wonder what's in delta time? That's all there is to it. That's just one number. That's all delta time is. 2806. 2.8 seconds has passed. This is how many seconds have passed. This is microseconds. Sorry, these are microseconds. If I divide this by 1 million, it's 18 seconds have passed since I last hit the breakpoint. You can add other variables too. Like maybe I want to see what's in the clock. There's what's in the clock. I can look at velocity. Look at acceleration.
Can you change that to seconds instead of microseconds?
No, this is always stored as microseconds. But because you can change those variables, sometimes you can use that to your advantage to kind of figure out what's going on. I would say that most of the time, if you're not sure what's going on, you put a breakpoint in there and you start looking at the values of like the position here. Look at the values of like, hey, is it actually even on screen? Look at like the color. Make sure the color is something that actually is something that can be drawn. Like this thing is green and it's 255 for alpha. All right. So if you're ever not sure why something is happening, like I can't move the paddles, consider using either cout debugging or using Visual Studio. I could actually spend an entire class talking about in detail like how Visual Studio debugging is, but I really want you guys to start trying to use more of this stuff on your own to figure out what the problem is. Otherwise, like it's going to be really hard to get over those humps. Like you're going to hit these problems like something's not going to be working, and the way you solve them, you can't just like trial and error. You can't really try something and see what happens. The way you should be working is you should be debugging and identifying exactly what the problem is. Programming is kind of a science. It's an engineering discipline, which means that you need to have a scientific approach to solving problems, which means you need to find out exactly what the problem is, the root cause of these issues. Okay? All right.